are discussing about directional derivative. The directional derivative of z equal to f of xy in the direction of a unit vector u is given by del f dot u. The directional derivative of a function f in the direction of a unit vector u is given by del f dot u. So this is the formula for finding out the directional derivative, del f dot u. That means the gradient of f dot the unit vector. This gives the directional derivative of the function f. So now we are discussing a problem. Find the directional derivative of f of xy equal to x e raised to y plus cos xy at the point 2, 0 in the direction of the vector I plus t. So to find out the directional derivative, first you are given the function f of xy. You are given the function f as x e raised to y plus cos xy. So first you write the function f of xy as x e raised to y plus cos xy. To find out the directional derivative, first we have to find out the gradient of f. The formula is del f dot u. So first find del f. The gradient of f we have to find out by the formula I dou f by dou x plus j dou f by dou y plus k dou f by dou z. So for that, find dou f by dou x. Dou f by dou x is the partial derivative of this function f with respect to x. So you treat y as a constant one. So first term is x e raised to y. The derivative of x e raised to y with respect to x is e raised to y you treat as constant into the derivative of x with respect to x is 1 plus then cos xy. Cos xy derivative is minus sin xy minus sin xy in. So dou f by dou x is e raised to y into 1 minus sin xy into the derivative of xy with respect to x is y. So we get this as e raised to y minus y sin xy. Then similarly you find out dou f by dou y, the partial derivative of f with respect to y. So partial derivative of f with respect to y, here if you look at this, the first term is x e raised to y. So derivative with respect to y, then keep x as constant. X into the derivative of e raised to y is e raised to y itself. Again cos derivative is minus sin xy into the derivative of this angle xy with respect to y, that is x. So we get this as x e raised to y minus x sin xy. Then if you look at the expression f, there is no term involving z. That is the derivative of f with respect to z is 0. Thus we get del f as dou f by dou x I plus dou f by dou y j, that's equal to e raised to y minus y sin xy I plus x e raised to y minus x sin xy j plus dou f by dou z is 0. So del f is, you get del f like this. Then find out del f at the point. We have to find out the gradient at the point 2, 0. So find del f at 2, 0. Del f at any xy point is this one. So putting x equal to 2 and y equal to 0 in this expression, we get gradient of f at 2, 0. So if you put y equal to 2, y equal to 0, you get e raised to 0 minus y is 0. So this term is 0. I plus x is 2, y is 0. So 2 e raised to 0 minus here y term sin 0. So sin 0 is 0. So the second term is 0. So you get this. So you get e raised to 0 1. So this is I plus 2j. I plus 2j. So del f at 2, 0 is I plus 2j. Then we have to find out the directional derivative. In the definition of directional derivative, the definition is for along the direction of a unit vector. So here we are given the vector I plus j. So that's not a unit vector. So we have to find out the unit vector along that direction. So the unit vector u is equal to I plus j is not a unit vector. So we have to divide that vector by its length. The length of this vector I plus j is square root of its I square, I component of I square plus component of j square. So here component of I is 1. So 1 square is 1 plus component of j, that is 1 again. So its square is 1. So we get the unit vector along the direction of I plus j is I plus j divided by root 2. That's the vector. If you want, you can write this as 1 by root 2 I plus 1 by root 2 j. That is the unit vector along the direction of the given vector I plus j. So next we can find the directional derivative. So directional derivative is, therefore directional derivative equal to, the definition is del f dot u. That's equal to, del f we get as I plus 2j. Del f we get as I plus 2j. So I plus 2j dot u, the unit vector we get that is 1 by root 2 I plus 1 by root 2 j. So if you take dot product with these two vectors, we get the directional derivative. So how will you find the dot product of two vectors? So here we have to find out the dot product of these two vectors. So component wise multiplication. So here component of I is 1 and here component of I is 1 by root 2. So first the dot product you take as 1 into 1 by root 2 plus second take the component of j. Here the component of j is 2. Then the second vector component of j is 1 by root 2. Take the product of that. So we get the dot product as 1 by root 2 plus 2 by root 2. So the answer is 3 by root 2. So we get the directional derivative as 3 by root 2.